word. What is it called?
All right. Get out your notebooks and fill in your table of contents. We have this lesson and then one more and then we're done.
Wait.
Are you saying that? Another.
But then what's the lesson after that one?
We don't have any more units.
We have
We're done.
this lesson, one more, review, test, review for the final.
Oh. You know, I'm really.
For the final period before.
I'm serious, but I'm assuming nothing in there. Good. Good. I do know, this class is what I'm worried about. You're welcome.
Well, we won't know until.
See, that's what's scary. You can do it.
You can, I believe in you.
Do you? I think, oh, okay. I guess I'm trying then. I like how simple it is. I mean, it's kind of fun. It's like fun pictures, so it's okay. Don't tell me. I really thought that you're like sweatshirt said shoes. Says what? It doesn't say shoes, but I thought it said. It says shoes. Shoes.
Is it choose me?
All right, so you have a paper that says different types of sequences at the top.
Oh, that was the top. You got like fancy. Actually, I love all of them. I really like, I give up. It's like, I'm excited.
Okay, this one will go on page 146.
My notebook is full of them. I thought down in magic. The paper. It's not organized. Oh, why did I be on that?
All right, consider the function f given by f of n equals 3n minus 7. This function takes an input, multiplies it by 3, and subtracts 7. So evaluate each one of those 4 expressions. Okay, I believe in you that you can do this without me. So go for it. I'm going to have 4 answers here. Yes.
There are two that.
No, you don't want the monster ones. Those are for a different class. All right, compare your answers with your neighbor.
I did. Oh my gosh. I said yes.
I got three.
I don't know.
I just did,
Oh, wait.
Okay, so walking around, most of you already know this, but what does this actually mean? F of 10, what does that actually mean? X equals 10, so we take 10 and we plug it in, and by X we mean in. N is 10, so this would be 3 times 10 minus 7. What's 3 times 10? 30 minus 7 is 23. Very nice. Okay. Almost all of you had that one correct, so we're good there. Okay. Part B, f of 10 minus 1. So I'm going to take f of 10, which was what? 23 minus 1 is 22. How is that one different from part C?
Because you were before you plugged it in. So 9, so after you solve it, it plugged in.
Yes. You have to subtract first. So this is really saying f of 9.
Yeah.
So you take 9 and you plug it in. 3 times 9 is 27 minus 7 is 20. Okay, then part B got everybody all nervous.
It did scare me. Not really.
Okay.
Okay.
You have to take 5 and you plug it in. You take 4 and plug it in. But what do you do first? And then you subtract them. What in the world?
8 minus 5.
Okay. When you plug in 5, you have 3 times 5, which is 15 minus 7, which is 8. Minus, when you plug in 4, 3 times 4 is 12, minus 7 is 5. And 8 minus 5 is actually 3. Okay, how's that for some Algebra 1 review? So fun, right? Could be worse. Could be rationals.
Not food. That word.
Those fractions of your nightmares. All right, so here's 3 sequences. The first 5 terms of 3 different sequences. On your paper, for each term, describe one way to produce a new term from the previous term. So basically, you're writing down the pattern. If you get stuck on the second one, skip it and go to the third one and then come back.
No, it's not.
Okay.
Yeah, 5, then you had 10, then you had 20.
Yeah.
Started out right. You said it wrong, but you were on that track. Okay, what's happening on part A? Let's start there. Yep, you add 10 each time. Okay, what's happening on part C? Multiplying by 2. Okay, what does it mean for, what kind of sequence is it if you multiply every time? What we talked about last time? Yes, geometric sequence. And it's geometric because we multiply by 2 every time. So we're multiplying by the same thing. Okay, and then part B. Jonathan, tell me what you were saying on part B.
You add 5 more than the last time.
Yes, so from 0 to 5, we added 5. From 5 to 15, we added 10. From 15 to 30, you add 15, and so on and so forth. So you add 5 more each time. All right, so now I want you to look at those sequences for just a second, and I want you to think about that next question on your paper, which asks, which sequence would have the second greatest value for the 10th term? So which sequence would have the second greatest value for the 10th term? Don't do any math, just look at it and try to guess. All right, now turn and talk to your neighbor about it.
Wait. No, wait.
All right, so circle, right here, circle which one you think is gonna be the second greatest, based on your math that you just talked about. Yep. And make you commit to one of them. Everybody circle one of them. Okay, now let's do the math. Okay, so we're gonna find the first 10 terms for each of these sequences. Okay, so everybody's doing this on your paper also. Find some space.
Hangman.
It does look like him. Alright, I'll give you a minute to do the math and then I'll make one of you tell me the answers.
That's cheating. Did you say circle the second biggest one or the biggest one?
Second largest.
Ashley. Tell me all this, the rest of this sentence, or sequence. Yeah.
Awesome. 80, 90, 100.
Yep.
120.
Yep.
130.
Okay.
Actually, I was 130.
Charles, yeah.
Get back to me.
Yeah.
All right. Now, who wants to give me sequence B? John? Yeah.
75. 110.
105.
105. There we go. 140. 180.
Two what? Okay. And who wants to give me the last one? All right.
Then 32, 64, 128, 256, and then 520.
Very nice.
28 days. 2048. Play that game one. Add that number.
Yeah.
So 0.
What?
The game 2048.
Yeah.
Oh, it is.
Yeah.
That's kind of.
No idea what you're talking about.
Oh, what?
You just
You
have
have to look up number there. Okay, so were you right or were you not right?
Yeah.
maybe we're right if it's like the 30th. Then.
I mean, we were right. It's down to beautiful. He was like, the largest, okay. And then I was like, wait, no. The second largest. He was like, okay, B. And okay.
How did you know that it was B without doing anything for the math?
Because doubling.
You knew A would be smaller.
We knew A would be the smallest because it's increasing the least, right?
Mm-hmm.
Okay, what about part B?
I mean,
What was that? So you look at C, you know, it's gonna. I didn't really pay attention to part B. I was like, C is gonna be huge.
Exactly. Because it's geometric, it's multiplying every single time. The part B is adding, but it's adding more every time, so it would increase faster than the other one, right? Even though A started off with 30, B started off with 0, and C started off with 1.
Oh.
Okay, so which one was geometric? We already talked about that. C, because it's being multiplied. All right. Okay, now we have our next vocab word.
Okay.
It's an arithmetic, even though it looks like arithmetic, it's an arithmetic sequence.
is arithmetic even a word?
Yes,
Why is it not spelled like that?
it is sometimes.
Wait,
It's just not pronounced like that.
okay, that's really confusing.
I agree. Okay, it's a sequence made by adding or subtracting the same number every time. So which one of those sequences that we just looked at was arithmetic?
B.
A.
A, because A added 10 every time. B added a different number every time.
Oh.
Okay? So B wasn't arithmetic and it wasn't geometric, so it was neither one of those. You have three options here, arithmetic, geometric, or neither.
The same number.
Yes, same number. Same number, adding and subtracting. Which I remember on that one. All right. Now, Jada and I are trying to decide what type of sequence this could be. Jada says, I think this is geometric because the value column, each row is multiplied. Each row is 3 times the previous row. Mine says, I don't think it's geometric. I graphed it and it doesn't look geometric. So you, on your paper, not allowed. Do you agree with Jada or my? Explain or show your reasoning. So on your paper, tell me which one of those two you think is correct and why. So is Jada correct?
I mean, I thought so.
That's and then I looked at the term number and then instead of being wait. No, I missed.
Yeah. Okay, so Jada's not wrong. I mean, right here, it is multiplied by 3 every time, right? She's not wrong. That's correct. That's what's happening. But what Vivian was saying is that right here, this goes from 1 to 2 to 5. Okay, so we're missing some stuff right here in the middle. What are we missing?
Three, four.
A 3 and a 4. So if we have 1 and 2, 2 and 6, a 3 and something, a 4 and something, and then 5 and 18. If I multiply by 3 every time, is that going to give me this 18 right here? No. So what's really happening between these terms? They're adding 4. 2 plus 4 is 6, plus 4 is 10, plus 4 is 14, plus another 4 is 18. So my is correct. Not Jada.
We should
I got that right.
coming because the entire thing.
Did you guys overlay that? I just looked at the slope. And I was like, it's not.
Slow. What? You just keep that right there in your brain. Come back to that.
Oh,
It's
God.
like a
Because like the slope from 1 to 2 is different than slope
The rate of change.
I have.
Amazing.
I'm lost.
So,
Okay, no specific for the sequences.
are you not gonna connect the line on one? Or,
Sometimes you will, sometimes you won't, but like if you were to look at the graph of this one, it wouldn't make an exponential graph. It would make a line.
okay,
Because you're adding, you're subtracting the same number every single time. All right, that's gonna go on whatever page I told you was gonna go on it. Oh, no. You have this?
Do we still have like a full, like?
No. Okay, we'll come back. I'm not worried about that right now. Okay? That's gonna go on that page, then we're gonna do the sequences or functions one. On the next page, which is page 147.
not reading. I was trying to get, I needed video of that stuff. There were too many things happening, I had, it was a lot.
Oh, you need your paper.
Yeah.
I used my math class. I've been like this for 10 years now.
One.
What round are you taking it?
I'm taking college algebra.
He's like, oh no.
Wait. I like that.
Well, you're a math teacher. so-
I know. But it's all algebra, it's not geometry.
Yeah, it's gonna be
First
funny.
chemistry.
Where do you live?
All right, on your paper, describe how to produce one step of the pattern from the previous step and then draw in step 5.
Add another button.
Oh my God, it's like that game with the pigs.
Well, you added, I got the 7 on that.
Did you?
Yeah, then I stopped.
Oh.
So you do
In the correct number of moves?
No, 518.
Oh, well, hey, you made it.
It's like the 5-1 where you add one more.
I don't know if it's called for.
It's a neither.
Just add a row.
Yep, you're gonna add in step 5.
Yeah, runs in the step four, but that's okay. They don't know what person it is.
All right, check your neighbors. See how smart they are.
Oh, what was that?
That's fine.
I can't space
I thought you were supposed to tell us how to write a pattern.
And then I verbally said, draw it in step 5.
Well, there's no step 5 in the sheet, so.
I wrote in
Alright. How do I get from step 1 to step 2?
Add one more than there was previously.
You add a row.
Thank you. I'm gonna go with add 2.
Yeah.
Oh, dots.
Yeah, that's fine.
Okay, how do I get from step 2 to step 3?
Yeah.
Add 3 dots. From step 3 to step 4. And then from 4 to 5, we added.
I don't know.
5 dots.
That was too hard.
I'm sure I made that way complicated. All right, so when I went to step 2, didn't I add 2? And 3 added 3, and 4 added 4, and 5 added 5.
That's such a coincidence, like.
It's so crazy. Okay, if I wanted to look at the sequence, here I have 1 dot, and then 3 dots, and then 1, 2, 3, 4, 5, 6. Okay. Since I'm not adding the same thing every time, it's not arithmetic. I'm not multiplying by the same thing every time, so it's not geometric. So this is what's called a neither sequence.
Neither is.
I know, right? Neither, neither, however you like to say it.
I want to know if
Like,
I'm having
creative
to learn
model.
like this since I was like 13, when I realized that people say it different.
The British people.
Okay, so if I were gonna make a step 10, if I were gonna continue this all the way over here to step 10, how would I figure out how many dots I would put in step 10?
Obviously,
B plus 5. For step 10? Yeah. B plus 5. Or plus 10. Plus 10 from what?
9
From step 9, right? I have to figure out step 9, and then I would add 10 more to get to step 10, right? Okay, to get to 20, I'd have to know what 19 was, and then I'd add 20 to that to get to step 20, right? So I have to know the step before it to be able to get the next one. My word. I hate this. Okay. So using the visual pattern of dots above, the number of dots given is a function of the step number n. What values make sense for n in this situation? Okay, so what kind of step numbers are we going to have? Values of n. Am I going to have like a step 1.5?
No.
No. Am I going to have a step 2.25?
No.
Am I going to have a step negative 14?
There's dots there. So.
Maybe they're like upwards.
No, they just all been up there.
Do I have a step 0?
Yeah.
Yeah,
No.
zero.
There's 0 dots. Maybe.
Nope, we start at 1.
Okay.
So we're starting at 1, and it's going to be anything greater than or equal to 1 where n is a whole number. What is that whole number? Okay, so only whole numbers make sense, and we could go on forever and ever and ever, right?
That is greater than or equal to 1.
Oh my.
What's happening?
Okay. Number 2 says complete the table for steps 1 to 5. All right, so let's look at what in the world they have written here.
I think what I know.
Okay, so this is our starting point. So we started with 1 dot, right? What does this mean? E of 1?
Yes,
Dot 1. From before it. Dots from something. The first one, the step before it, right? So this is from step 1. So 1 plus 2 is 3. So what is D of 2 then?
Dots from the step two.
Dots from step 2, so 3 plus 3 is 6. So what am I gonna put right here? Dots from step 3 plus 4. So 6 plus 4 is 10, right? And then for 5, this will be dots from step 4 plus 5 is 15.
Wow.
Crazy.
Super crazy. Okay, so following the pattern in that table, we want to write an equation for d of n in terms of the previous step. Okay, so we're talking about for any step ever, d of n, any step ever.
Okay. I have no idea.
Okay, so think back to what we were saying over here about step 20, right? If this were step 20, what do I have to know first?
Step 19.
The answer to step 19. Well, how do I get 19 from 20?
Minus 1.
Think it. So I need the answers, and then from 1 minus my current step. And then what number is added over here every time? Somebody said it. 10. Okay, for step 5, we added 5. For step 2, we added 2. For step 20, we added 20, right? So this is the step before it, plus the number of step that you're on, right? Where n is greater than or equal to kind of, sort of. Understand where all those pieces came from? All right. This next thing I'm going to show you is probably the most important slide of the whole unit. Not the lunch one. Nope, not this one, I lied. The recursive definition, this is not the most important one. The next slide is the important one. There will be vocab.
I'll make another word thing. I mean,
I asked her for that last test and she said,
I was like, I don't know what word to use.
Okay, but I did warn you that that would be there.
I forgot.
All right, a recursive definition is defined using one or more previous terms which are given. What? Recursive definition is when a sequence is defined using one or more previous terms which are given. There are 3 parts to a recursive definition. This is that most important slide I was telling you about. This is not written in on your notes. You have to write all these things in, and you need all of these things. So write them down. Sorry, not sorry. What?
Or, you know, with a note.
Let's try this.
"No, minus one."
Whoa. Didn't break, did it? Okay. Just making sure. I promise I'm going to explain what all of these letters are talking about in just a minute. I'm just giving you a minute to write them all down.
I read step numbers.
What do you?
All right. So 3 parts to each one of these sequences. The first part is G of 1 or A of 1. Okay? What does that 1 mean?
First step.
Step 1. So it's your starting point. Step 1. Okay, the next part, G of n or A of n, is your general rule. That's how to find any other step ever. General rule. Okay, and then the last part is your domain. You have to give a reasonable domain for your sequence, which will almost always be greater than or equal to 2. Most of the time. Does everybody have that written down? Right here, on the arithmetic sequence, it says common difference is also called a rate of change. Okay, rate of change you've heard before when you were talking about slope. Okay, just the common change between each point. Seen that before in a linear function. What does a geometric look like when you graph it? Starts with an E. Exponential. What does arithmetic look like when you graph it? L. Linear. All right. We talked about this. All right, so it says use the first 5 terms of each sequence to state if it's arithmetic, geometric, or neither. Then define the sequence using function notation. Okay, so part A, that sequence should look familiar.
Oh, wow.
What is it?
The 10.
It's adding 10 every time. So if it's adding 10 every time, is it arithmetic, geometric, or neither? Arithmetic. So it's an arithmetic function. If they're adding 10. So we are going to write our recursive definition using all 3 parts. So the first part, we have to start with our first step. What is our first step? 30. It's our first term. Okay, to get any new step, you have to take the one before it. So find any step A of n. You have to find A of n minus 1, or the previous one. And add 10 to it. For n greater than or equal to. Okay, if we started with step 1, we're going to use this rule for anything greater than or equal to 1 more than that. So 2. So for step 2, we would take 30 and add 10. For step 3, we would take 40 and add 10. This right here, this n value is always going to be 1 more than whatever you have right here.
Okay.
Because it's
You don't have to start at one.
right.
We're gonna do it 1.1.
Because you're not going to have a 1.1 step. We talked about earlier how you have only whole numbers, step numbers. You're not going to take that half a step. Like physically, you can take a half a step, but like on these, you're not going to have half of something. The other day when we talked about cutting paper, couldn't have a half of a cut, but same thing.
I don't agree with that.
Part B, what's happening between all of our sequences? Between all of our terms of our sequence. What?
Multiply 1/2.
Multiply by 1/2, so is it arithmetic, geometric, or neither?
Geometric.
Geometric. We're multiplying by 1/2.
I was ready to multiply size.
So, this this sequence, I'm gonna use B. Our first step is what? A. That's where we started with. To get any new step from that one, we multiply 1/2 times the term before it. And greater than or equal to, if I started with 1, this will be 2.
2.
Okay, so I have all three parts. I have my starting value, I have my general rule, and I have my domain. Okay, try part C. Just part C. Don't move on. Just part C.
Hey, welcome.
Okay, before you move on, let's check this one. Okay, what's happening between each term? Multiply by 2, so is it arithmetic, geometric, or neither? Geometric. Multiply by 2. So what's my starting term? 1. C of 1 is 1. To get any new term, I multiply the 1 before it by 2, so 2 times C of n minus 1 over n greater than or equal to, I started with 1 over there, so this will be 2. Sometimes, like on the homework, maybe on the review, if I remember correctly, they'll start with step 0. So if they start with 0 here, this would be n greater than or equal to 1, or just 1 more. Okay? Go ahead and try D, E, and F. If you get stuck on F, work with your neighbor. So this one was geometric, which you multiply by 1/2. Step 1 was 1. Get any set, you multiply them 1/2 times the answer to the step before it, or n greater than or equal to 2. Right? Okay, this next one was arithmetic, because they're subtracting 7. Our first term was 20. So you take the term before it, e of n minus 1, and subtract 7, or n greater than or equal to 2. Okay, part F was my favorite because it was a neither. Should look familiar, because this is our tower sequence the other day, right? Those are hard too. Start with 1. Get any new term. What do you do? Yep, multiply it by 2. Previous one by 2. So 2 times f of n minus 1.
And then
And then add 1.
I have,
I don't know how to do that.
okay, so the n, like the term, the variable n matters. Like,
Yes.
I know that one was asking. But do like D, E, and F, do those have to be okay? I was like, I don't know which one.
If it matters, they'll give it to you.
Okay.
They'll say using like D of n or F of n or G of n. It doesn't matter. If you wanted to do A of 1 every single time, that's fine.
Are you graphical?
Yes.
Are we gonna have to?
Wait, but is my
Yes.
way,
No?
is the way I did it right this way?
Right.
Totally commit to that no I just said.
Absolutely.
I think we've heard of those. That's a really good one.
I'm not gonna make you graph them. I might make you pull some points from a graph.
Oh,
Could be worse.